Okay. Hello. I I hope you can hear me clear and fine. Okay. Let me see if the stream started off fine. Let me go here. Okay. Seems just fine. Okay. So hello everyone. Welcome once again to my live stream of me working on my project for creating a traffic light with Arduino. This project entails a lot of like coding, circuits, and proper prototyping, also 3D modeling and printing. So this is day 4 already. I'm still working on the code. Hopefully, I will be done with it maybe like today or the next video or next time. Before I start, I just want to share something fun with you or something of me. Today I went biking for about let's see, it's like 3, almost 4 miles, and I loved it. I love biking. I just love the freedom of it. So that's something that you know about me now. Um, and I guess we can just get started with this. Let me just, alright, let me just put the timer. You can see my screen. Okay, this is going to be 30 minutes long. Today is Sunday, October 13th, 10:08 p.m. Uh, so last time I left up this, I left some to-dos here. This was on the 10th, and these to-dos, oops, sorry, um, are we, are what I'm gonna, these to-dos are what I'm gonna be working on, um, today or now. So my main goal right now is to add the study and break timers to the EEPROM. That way, the user you can modify the study timer and the break timer and have it be there permanently so that anytime that you want to use it, it's always there. You don't have to always increase or decrease the timer to your liking because it's gonna be default set. If the default value is gonna set to 30 minutes for studying and 5 minutes for break. Or I might change it once I look up what the research studies say the best combinations are. So I'll look that up. But now I just want to add the study and break timers to the EEPROM. So like I said before, right now we have the study timer and the break timer completely how do I say this? Default. It's completely default to what I put it to be hard coded into the program. The user has no freedom over that. But once the program starts, they can either increase or decrease these timers. But as of now, how it is that once that even though the user changed it, once program the board has been turned off or reset, those default values are gonna come back. So 30 and 5 minutes are gonna come back. Why? Because this data that the user modify is erasable once the program shuts down and turns off. So that's why I'm going to write these values. I'm gonna store those values in the EEPROM, the erasable el- electrically erasable programmable. Oh, okay. So it's electrically erasable programmable um, read-only memory. That's what it is. So last time I said that these values here are what I'm going to store. These are default values starting in 5 minutes. Instead of having what I had before, which was like having them in as milli in milliseconds. So 30 minutes in milliseconds is like a very huge number with like six leading zeros, which is a long number to store in the EEPROM. Since the one memory space in the EEPROM is it's about it can only store about 255 bytes, a byte of data. So and that's why I'm storing them as unsigned int. That way I can easily store this. And once I have that, I can just get the time or the yeah time in milliseconds by multiplying the minutes by milliseconds per minute. That way I can get a lot of I don't have to store all of those numbers in the EEPROM. So I here on my diff on my setup, I want to read. Okay, first you see here this zero and this one. Those are the memory spaces. Instead of me having them hard coded like this, I'm going to define them in the whole program so that that way the program's more readable. So I'm gonna do it's define study address is gonna be zero, and then there's gonna be break. It's gonna be one, but then I want all of this in break address, and then study address. That way, um, it's easily known and readable what that value is instead of just having it as um zero or one. So I'm gonna do instead of doing read, I'm gonna do let me see get because the read I have to do store that value in somewhere, but that the get I can just call this function this method and tell it the address and where to store the the data. So I can just say instead of this I can just say well EEPROM dot get study address comma oh yeah comma study timer, and then here's gonna be break, and then here's gonna be break as well. Let me just make sure that that's what they're called. Study timer, break timer, and then study address and break address. Okay. Let me just okay. So now I'm just working with this setup. Now, the first time this program runs, it's gonna be oh hold up. Because this the return value of this okay so the first time this runs this memory space is gonna be empty. It's not gonna have a value that we want it to have. It's gonna be empty because that's the first we have never read into that memory because it's the first time that we're running this program. So this might store a value that let me see if I can get this. Okay, does it say where it returns? Hmm. I'm on this one. So this is the data, and this is the address, and then it returns T, which is the reference, the dereference to the, okay. Okay, so this is going to be the pointer, alright. I'm just trying to see what this returns. Because here I was looking at ChatGPT and it was telling me that it returns, if the EEPROM is empty, value is -1, right? And it, sets the default value to -1. Um, so right now the way that I have it, you see this timer value, this one, unsigned long is comparing it to Alt F because that's what happens when it's an overflow. What happens when an unsigned is given a is set to a negative number? I think it's a overflow, underflow. Yeah, so I can. This is my. If it is empty, it's gonna return something else. Here, return T. I'm not sure what this is gonna return. The size of T, count, decrease count, and pre increment E. What is E? The index. Okay. What I think I might do is instead of doing this, if EEPROM that read from study address is equal to -1, I'm going to say, um, well, I'm gonna say if it isn't, right? Because if it is, I don't want it to do anything, right? I just want it to keep this value. But if it isn't, I'm gonna say, well, since you're not empty, okay, since you're not empty, I'm going to tell you to EEPROM that, okay, how do I play this? Because I don't want to call this function twice or call this one and then get. That's just gonna be two necessary calls. So I think I might just store into a value here that might be int temp and then equals to and then I'm gonna say temp and do this. If temp isn't equals to oh no, never mind. I don't need this. I can just do -1 and then I can say study timer equals to temp. That's what I think I would do. And then if this one is an empty, right? If this one is an empty, then well, you we might change the study timer, but we might not change the break timer. So let's see. Yeah. So we need to also add it here. So I'm gonna do temp temp1 and 2. I'm gonna say what? I need to add this here, oh, this here, and so I'm gonna say break. There you go. I just want to see something. Hmm. Okay. I want you to read from the break address, and if it isn't -1, then I want you to say break timer. Let me just make sure I update this one. Okay. And then I'm gonna say instead of you being whatever this is, I'm gonna say break timer. Oh, no, this should be study timer, and this should be break timer. No, this is wrong. Then I can just say this and this should be break. Reach break time from EEPROM, or is it reach study time from EEPROM? I'm gonna say here checks if value is memory if address is empty. There you go. Let me there you go. So I have a default value here. I have it set up to this, but then I'm saying, well, if the memory, if the value at this memory space is -1, meaning meaning it's empty, then no, if it isn't empty, okay, if it isn't empty, then set whatever the set the study timer to whatever value is at there. It's there. But if it is empty, leave it as it was with the default value. And then here it's the same for the for break timer. I'm saying, okay, I want to convert this to milliseconds, which is this. So the timer times milliseconds, and that should be fine. And now here, when I'm writing to this, I'm gonna say study timer, and I'm gonna say study timer. I'm gonna say break timer. This break function, let's see, right, require get put read right here. Oh, okay, yeah, this is what I was going to talk about. This write function writes to an address, but it writes a value, expects a value from 1 to 255, like the bytes. But I want to make sure that I want to make sure that I want to write whatever is at that variable. So I'm gonna do put, which that writes this method writes data on an EEPROM using also the EEPROM update. Okay, and then the number of bytes written is related to a data type or custom structure of the variable to be written. So whatever that variable is, and the size of it, it will put it in the EEPROM. So I'm gonna use that better. I'm gonna do put, and once again, it takes the address and then the variable, which in this case is this, right? Then it's gonna go put and then put here as well, and then also here put put. Let me just check this just in case. Okay, let me go through again. If it is to increase the time, then I'm increasing the timer, and I'm updating the interval, and I'm putting that on my EEPROM. Okay, starting timer +1 and decrease this one, so I need to do minus. Right, here as well, so that should be good. Oops, sorry. I'm used to the VS Code shortcuts. So instead of doing Control S for saving, I did Control K plus S, which saves all the files in the project folder. And I did it here. I was like, what? um, so I think the next step, or let me see something. Let's say I did this, right? And then show time for just break state. Okay. So the issue is that when we're adjusting the how do I call this? Just the time for either the study or break, we are not displaying the time. The time on the are displaying by this function here in the loop, which says if the stays idle, study, or break, we're gonna display the time. So we can just say here, um, current state. Let me just do this. equals what are they called? Adjust study and adjust break, which is adjust study and then adjust break. Um, this might be irrelevant now because here these are all of our states. Idle, study, break, adjust, study, adjust, break. So I can just say all the time, always display remaining time. And the remaining time, this variable depends on what state it is. If it is on the idle state, it's just gonna say, it's just gonna be 30 minutes, like the study time. It's just gonna be that, right? Or if it is in the current state, if you're gonna be in the study state, it's gonna be decreasing. It's gonna be the same for the break, and for the just study and just break, it's gonna always change it, show the time that the user is changing it to. So I think that should be okay. Let's say I did that. Um, let's say this done. Okay, I also did this, define a fixed time intervals because I already did that. These intervals are what are the timers, the minute in minutes, and compare it to milliseconds. Let me check. Okay, there's 5 minutes left. I think I'm gonna wrap it up here. Next time I need to I'm going to test this, and what I need to test this is the physical. I need the breadboard, which I don't know where. Oh, I think it's here. I need the breadboard. I'm gonna hook up the Arduino here, so it is connected to this bottom here, which is gonna be the input, the events for this program. Because once again, here this program takes in the input from this bottom, and depending on the time the bottom is pressed, we can have three events. So in this case, we have, let me just here, single press, we have double press, and we have long press. So next time I'm going to hook up the Arduino on this, and I'm going to test it. Also, what I might be able to do, instead of having to use the hardware, I can use a online builder which is called, see, Arduino Simulator, I think it's called. Yeah, here it is. This I have used it some time ago, but I'm gonna use the Nano, and let me, oh, here I can add a push button. Let me see something. Let me try to copy and paste all this. Okay. I'm gonna say library manager bottom, what's this called? BF bottom fever. Here it is. Nice. And I need to see EEPROM. Okay, let me see how this runs though. Oh, there's a walkie for VS Code. That's interesting. Yeah, I didn't check. I didn't. Let me compile this here and see if there are any. Okay, here. EEPROM put a study. Oh, here. It's a study address. Address, and then here should be Yep. Address. There you go. Compile this again. Okay, no issues. I'm going to go back here. I'm going to cancel this. I'm going to say this. Um, compiling. Oh, there you go. Can you see this? Right now it's in the idle state. You know what? Let me so we can easily see this. I'm going to uncomment this. I'm gonna say study break. I'm gonna say I just study, I just break. I'm gonna say stereo the print new line. I'm gonna say adjust break. No, just study. And then I'm gonna say here, oh, my bad. There you go. This is break. And then here in study, I'm gonna do this. I'm gonna run it again. So based on this same machine, once the program starts, it's gonna directly this is gonna be the default state, the idle state. So if we go back here, see, let me just stop this. Oh, that's nice. So here it's way too fast, but you can see that it says 30. It displays the time, which is 30 minutes, and then also displays idle, which is it also displays idle, which is this. So yes, um, I think I can just tomorrow. Okay, no, not tomorrow, but I don't want to say tomorrow. Next time I do this, I'm going to hook this up. I'm gonna use the simulator better, see if it works, and then I will instead of using the physical breadboard, I'm gonna test it here with this push button and this Arduino Nano board, which is what I will be using here on my physical breadboard, and then we'll test the code if the transactions are right, if the conditions are right, and also if the study and break function correctly. What I think might not work is the EEPROM writing because this is a virtual simulator, so I don't think it's gonna work. But who knows? We'll see. But yes, thank you for joining me today. Oh, you know what? Let's do this once again. Um, no, let me see. Nope. Okay. So let me go here. No. Oh shoot. Okay. Copy. Today is the 13th. I got this. Okay. Build simulator circuit and test it. That's gonna be for next time. Hopefully tomorrow, Monday. Um, and yes, we're getting close to this, so hopefully we can accomplish this very soon. Thank you for joining me, and I hope that you like this and that you learn from this and that you know that you can join